Alright, if you watch another video, you might have already heard this joke, but I think I'm really funny, so I'm going to make the same one all over again. And we need to address an elephant in the room, and that elephant is me. And the fact that you can see me in my videos now, and you might be saying, Mr. Schwartz, I see your face all day long, and I'm so tired of it, it really hurts my eyes to have to look at that for so long. But I'm going to be in the videos from now on, so I'm so sorry. You can just focus on the notes. Speaking of notes, here we go. Today we're talking about multiplying decimals. We talked about it in class, and I gave you a really confusing explanation about why it works, this process we're going to use. But first, let's just take the notes of the process because that's the easier part. When you're multiplying decimals, the first thing you can do is ignore the decimals and just multiply like normal. Just follow the same thing when it comes to carrying and to place holding for place values, and just multiply like normal. Ignore the decimals. But we still need to have a decimal in our answer usually, so we need to add the number of the decimal places in each factor. That says the number of decimal places, not the numbers in the decimal places, but you have to count how many numbers are after the decimals and add those up to get a sum. Finally, we're going to move the decimal back into our product. Product is the answer that we got when we multiplied like normal, and we're going to move that decimal back in however many places we added from the first two factors. The final note is you do not have to line up decimals when multiplying. We made a big deal that you do when you're adding and subtracting, but not when you're multiplying. So, I still want to make sure we understand that, math usually makes sense. In fact, it always makes sense. And so you don't just have silly rules that work out for no reason. They always work out for a reason, and I'm going to show you what that reason is, why this process will work. You don't have to take these notes down, but I would appreciate if you paid attention so you understand why it works. Let's take the example of what about 2 and 1800ths, and what if we're going to multiply by 6 times. So you can see that I didn't have to line up the decimals, and that's a great thing. Now, the first note said we're going to ignore the decimals and just multiply like normal. 6 times 8 would be 48. I like to carry that 4. 6 times 1 is 6, plus 4 is 10. Okay, I would like to carry that 1. 6 times 2 is 12, plus 1 is 13. The next step we said was to count how many decimal places or how many numbers are after the decimal in each of the factors. So in this one we had 2 numbers after the decimal. That was the 1 and the 8. And then the second number we have 1 number after the decimal. So we add those two together, and our answer, our product, needs to have 3 decimal places, or 3 numbers after the decimal. So originally in this number, when we just pretended it was 218 times 6, the decimal was right there. But we need to move it 3 places to the left. Oh, that's gross. Doesn't look the best. But then your answer would really be 1 and 308 thousandths. Now, why does that make sense? Why are we just allowed to ignore things and then put them back in? Let me show you what's really happening. We were treating this like it was just 218 times 6. We were saying that that number, 2 and 1800ths, is just kind of like 218 times 6. But that's not equal. Those aren't equal right now. So we need to finagle a little bit, change them around. How could I have 218 really be equal to 2 and 1800ths? Well, I know that the decimal just has to move, or the place values have to shift, really. And my decimal is currently right here. To move it twice to the left, I can divide by 10 twice. And to move this decimal once, I can divide by 10 once. Now it's equal. This is an equivalent expression. 218 divided by 10 multiplied times 6 divided by 10. We just wrote it out in a really long way. Then we multiplied and got 1,308. But the reason we had to still move the decimal back in is because we need to account for this division by 10 that we need to do 3 more times. And that's what's going to move our decimal back in. We'll move it in. So that once we divide by 10 3 times, our answer is 1 and 308 thousandths. That might look confusing to you. You do not have to do that on every problem. I just want you to understand that there's a reason this works. Now, if you're really astute, which means, level-headed, paying attention really well, a good student who is super focused and trying to pick up as much information as possible, if you're really astute, you might have said, Mr. Schwartz, you said that 218 should be divided by 10, but you multiplied first. Are you allowed to do that? We actually are. That's called the commutative property of multiplication. So it's kind of like saying that instead of dividing by 10, we can multiply by 110. We'll talk more later this year about why that works. Multiply by 6 times 110. And the commutative property says that you can when you're multiplying things, you can multiply them in any order you want, as long as you're only multiplying. So we multiplied these two first, and then we multiplied times the 1/10, and that's what moved our decimal back in. Let's do some normal examples where we don't have to worry about all this craziness going on. All right, number one, Mr. S earns 400,000ths of a dollar. That's less than 1 cent, much less. From YouTube for every video he makes. If he has 33 videos, how much has he earned? What do we need to know here? Well, we said it was 400,000ths per vid and 33 vids. So let's do that multiplication. I'm going to put 33 on top. 1, 2, 3. And we'll multiply by 4. 4 times 3 is 12, carry 1. 4 times 3 is 12, carry 1 is 13. And then we just can fill in a lot of zeros because I know we need to move our decimal back into the answer. We ignored it at first, but this number has 0 decimal places. This number has 5 decimal places. My answer better have 5. So I need to move this decimal 1, 2, 3, 4, 5. And we get 132 100,000ths. There we go. And it's money. We're talking about money. So it's not even a cent yet. Not even close, really. But such as this light. Maybe if I talked about cod, I would earn more, but I'm not going to talk about that. 2. At the grocery store, steak can cost about $6.78 per pound. If you buy 2.5 pounds, a 2.5 pound steak, how much will it cost you? This is multiplication just like the last one, because we have repeated addition, something that's being added over and over again. So each pound of steak, you need to add this amount for every pound you have. So steak is $6.78 per pound, and we get 2.5. So 2.5 sounds like 2 and then 1 over 2, but you should know that 2.5 as a decimal is 2.5. 2 and 5/10, because 5/10 is 1/2. All right, this is multiplication. Let's see what it looks like. 6 and 78/100 times 2 and 5/10. Again, we're just going to multiply like normal. So here we go. 5 times 8 is 40. 5 times 7 is 35, plus 4 is 39. 5 times 6 is 30, plus 3 is 33. Placeholder 0, because we're now multiplying by that tens place, since we are ignoring those decimals. 2 times 8 is 16. 2 times 7 is 14, plus 1 is 15. And 2 times 6 is 12, plus 1 is 13. Add them up. 0, 15, 9, 6, 1. And where does our decimal go? Well, we have 2 decimal places in the first factor, 1 decimal place in the second factor. Add them together. My answer better have 3 decimal places. So it will cost $16.95. I wonder if this will work. Oh, I was going to try and draw a picture on my face. Oh well. That is the notes. Those are the notes. Well, gotta have agreement in your language. Those are the notes for today. Here are 2 problems I'd like you to work on your own. Best of luck. I'll see you soon.